So today we'll be going over hazard material awareness. This class is a intro, just making us aware of some different hazmat stuff and how we as paramedics can deal with hazmat type situations and where we kind of fit into the general care. So first off, what exactly is hazardous materials? Hazardous materials is a substance or material capable of posing a risk to health, safety, and property. More than 50 billion tons of hazmat material are made in the United States each year. And examples where we deal with them, vehicular crashes or something else of that nature. It can be an incident at a facility that we are responding to after the fire department starting to take care of it, and we're just kind of fitting in to the overall scheme, and we might be transporting these patients. And injury or illness can also result in chemicals mixed equals hazmat. Focus placed on handling hazmat materials. Major incidents have attracted attention of employee and citizen groups. Everyone from like local, state, and federal, everyone has something to do here, and it's resulted in more laws and regulations regarding hazmat. There's a lot with that. Typically, with most places, if they have hazardous material and seeing like a lot of it, they tend to have, especially in industrial areas, they have their own response there. The super fundamentals, that's a thing. And but basically, what this allowed it to do is intended to help communities better manage a chemical emergency. OSHA and the EPA started coming up with the minimal levels of training and steps at the awareness level. Getting as many people, particularly that are responding, that at least to the awareness level, so they can recognize that it's a hazmat scene and what to kind of do with it. NFPA standards, and they came up with standard for just EMS personnel responding to any type of these incidents and how to do that. And what it all involves with is analyzing the scene, recognizing it's a hazmat scene, getting the appropriate resources on scene, getting ALS care to the patients, and implement a pre-hospital plan. For those that actually do more into it, they'll get into the hazmat operations level. We don't get into there. We're at the awareness level, most of us. Hazmat's a unique thing, and we're not always my favorite side of things, as far as crazy little things that can kill you super dead before you know it, or long and slowly dead and still pretty bad. So with that, ALS care in general depends on a few things. It's generally accepted practices of hasty decontamination and mitigation recommendations set forth in the safety data sheet or the ERG. And we're going to go over specifically in class on some of the SDS stuff in the ERG. We'll kind of look through and get some examples of it. And it's a very, very helpful book as far as the ERG goes, the Emergency Response Guide. And then the safety data sheet is something that every place that has any type of hazardous material of a certain quantity has to have. Almost every, like schools have them, we have them here. Every place that has some type of hazmat material has a book in there at their site for that. Many times, like most of the private ambulances, stuff like oxygen, things like that, and they have that. Hey, or they add a decent amount of cleaning supplies here. Here's what cleaning supplies we have. Here's all the safety involved with it. So if you ever do show up on a scene somewhere, you can simply ask them, hey, where's this safety data sheet about it? Pulls it out and it gives you much of the information about that specific chemical that they have there. So there's a couple things when we're trying to deal with hazardous material and identifying what it is. There's the informal product identification and the formal product identification. We'll go over some basic identification tips here. An informal product identification may be able to determine presence type. If you're visualizing a scene, you're not sure what it is, use binoculars. Old rule of thumb, if you can't fit your thumb over it, you're too close, and you're looking at it and your thumb out in front of you. Verbal reports what they said. The occupancy types, like a big industrial one, you might have an idea. Pool cleaning supply, probably got some chlorine going on, things like that. incident location, location within the building, visual indicators, smoke, weird smells, things like that. Sentences, container characteristics. Like if you look at a propane container or truck or even just a propane tank, it's under pressure. And we'll look at a couple of those, but the pressure, things that are under pressure, the tanks tend to be round at the ends versus just a truck hauling water or whatever other substance in there that's non-hazardous but not under pressure. Those ends tend to be, they might have a little bit of convex to them, but they're not rounded. Doesn't look to be under pressure, but then sense and symptoms are patients too. Some formal product identification things you can look at. There's about one or more of the 6 different systems: the American National Standards Institute, DOT, Global Harmonized System of Classification and Labeling of Chemicals, International Air Transport Association, and FBA. And this is where you see all the diamond shaped and signs on vehicles and outside of buildings. We'll look at some of those. So first we look up the NFPA placard consists of 4 diamonds within a larger diamond. The 4 diamond, as you can see there, it has blue, red, yellow, and W. So the one at the top, red, is how flammable, and these are on a scale of 1 to 4, 4 being the most severe and 0 being no severe. The white at the bottom, we'll talk about, it has a little bit of specialty. Yellow is instability. Blue is health hazard, and white depends on what it is. WC with a cross means don't put water on it, like phosphorus or other pure metals, soft metals, because they alkalitic metals, if you will. Sodium, some of the other ones that explode when you put water on them, white phosphorus or phosphorus. They have there's a few different ones on there, oxidizing, things like that, and there's a couple different specialty things that I'll put in that bottom corner. You will see those. You can go to your work at the private ambulances that they have them. The bigger fire department areas do too, but they'll have it in there and there's not very much on there, but they also have like because they have big old tanks of oxygen all over that place. So fighting a fire there, we've got to be cautious because we know that fire has a propensity to burn hotter as well as have projectiles shoot at you if those tanks holding oxygen fail. Some other different ones. You have some different health hazards like carcinogens, mutagenicity, reproductive toxicity, respiratory sensitive, toxic organ toxicity, flammables, pyrophorics, self-heating, emits flammable gas, explanation, gases under pressure, corrosions, explosions, oxidizers, aqua toxicity, or keep toxicity. There's quite a bunch of these different ones out there. And then we have the placards and shipping papers. And this is everyone, so they either have the UN or North American number on them, and they can be displayed at the bottom of a placard, and we'll talk about some of the different placards that you'll see on vehicles. There's a whole system there, but it also helps you identify what chemicals in there, even as a paramedic, and we'll quickly talk about those here shortly. So here we are, we see some, and they're based into 9 separate classes. Class 1, we have different types of explosives. These can be even, if you have a certain amount of even ammo for bullets, we had to have these placards on our trucks when we're carrying those. Not overseas, but when we're going out the range or something, we had to throw hazmat placards on them. Then you have your gases, all the different types of gases, whether it's oxygen, flammable gas, inhalation, hazards, or non-flammable. And then you have flammable liquids and combustible liquids, flammable solids, or similar to there. Then we have our oxidizers, our poisons, radioactive. We'll see that occasionally around here. And then corrosive or miscellaneous. Many times those be miscellaneous on there. Safety data sheets. They give a bunch of information on the piece of equipment itself, or not the piece of equipment, the hazardous material in there that they are transporting or that they have on property. It's supplied by the manufacturer and has all the product information, all the different toxins, everything that it is about it, and how to treat it. So ERG, everyone should have one of these in their ambulance somewhere, and I know, but it should be in there. So in this guidebook, we'll go a lot more into class, but it's pretty useful. It's this published by DOT, Transport Canada, and Secretary of Communications Transport of Mexico, and regional poison control centers have been established amongst the United States. Now I use these. You can get a hold of poison control too via the same thing. And there's a method to it. We'll go through it in class. I'll get more into it. It's really useful, and it can give you a bunch of ideas and of one, how close you should even be, and what you need to do with this chemical. There's an online app. There's a both Google Store app and a Apple Store app. They both have this. Not a bad idea to have that on your phone to quickly help identify some of these, and it's even easier to use than the ERG itself. ERG is still relatively easy to use once you kind of get an idea of what's in it and how it works. But as we'll go through this and get more into it in class, but the white section, information on placards, rail cars, pipelines, and trailer identifications helps you break down the container types. Yellow helps you identify the specific chemicals that are part of each incident via the 4-digit UN number. Blue identifies it in alphabetical. If you can't find it easily in the yellow section, then once you figure out what it is, you go to the orange section. Orange section will tell you how to deal with it. What PPE you should be using, evacuation procedures, first aid, spill and fire control measures. And then green is the section contains information regarding inhalation and water reactivity, small and large spills. So it's really useful to have and to know if you need to drive even further away or what possible issues they might have as far as care. You can also once you figure out what the chemical is, get a hold of the poison control and have them help guide your care slightly. Just because there's so many different weird hazmat things out there, they'll give you some ideas on what you should be doing. We'll watch this video in class. So identification of hazardous materials, Chemtrack is the other one. Chemtel that you can get a hold of them and you can tell them what you have and they can help organize and get things going as well as direct care. PPE. So this is some of the PPE stuff that they do ask on some of the tests. I will show you which ones to look at for and what to know. Protective respiratory devices, potential for exposure of the respiratory system to hazmat is super important. Air purification relies on respirators or filtration devices. We'll talk about both. Atmospheric supplying devices rely on a separate source of positive pressure to supply air. SCBA is self-contained breathing apparatus, and it helps it's just what the firefighters believe to wear into a burning building, things like that, and they have it for hazmat too. Many times it's the same. And then SABA supplies air via airline hose. We talked about this a little bit in TRT class as well. It's one where there's a hose supplying them some fresh air instead of a tank on their back. Classifications of protective clothing, disposable or reusable. There's two basically different kind of sets. One's disposable, one's reusable. Made from a variety of materials designed specifically for certain chemical exposures. No single material is compatible with all chemicals. So many times that they can, particularly if they have a certain one on site, they'll know, and they'll also know which ones to move into the actual operators level and the specialist level. So we talked about the different suits. This is something that is on your test on National Registry, as well as your high stakes. Level A is the highest, and it is fully encapsulated. There is no part that is exposed, and they basically almost have double layers on. Level B, their SCBA's in the outside, but they're contained within they have a SCBA on them, and they're breathing their own air. Level C, fully enclosed, but instead of a breathing apparatus, instead they have a filter mask, and that helps keep everything out. This is like the gas mask that the military uses. That's basically what we would wear for our MOPP gear. And then level D is basically work clothes with some safety glasses and gloves. So level A, highest degree of protection against both dangerous liquids and gases, fully protects your eyes, lungs, skin. You're required to don a SCBA while wearing one, and it's on the inside on these. You can see most of them are disposable. A lot of them stuff. Level B is that it won't protect you from airborne particles. It'll still protect you against liquid, and you'll need a full face SCBA. C, once again, is no SCBA, just an air purifying respirator or a gas mask, if you will. And the rest is you're still fully encapsulated. Level D, just a pair of coveralls, boots, and goggles. In fact, that's what many construction workers wear since most sites contain no. However, it's beneficial to wear level D that you have protection against battery leaks, chemical cleaners, and other small scale dangers. Should not be affected adversely by hazardous materials, decontaminated or discarded all of the gear properly. The donning and doffing of hazmat is a very unique and kind of challenging procedure, and they have to try and make sure that they take everything off, kind of like how there's ways you're supposed to take off your gloves and ways that to make sure that if you pull it off from the back and inside out and then right in the trash can, you reduce the risk of skin-based transmission of whatever chemicals there. All right, health hazards. So these are some examples of some of the different health hazards and the signs that will go with them. They may enter the human body by inhalation, injection, or hand absorption, result in internal and external damage. Exposure to poisons can reduce acute toxicity, delayed toxicity, and local and systemic effects. There's many like this example, like carbon monoxide. May involve respiratory tract, central nervous system, or other internal organs. Physical injury may vary. Some different health hazards. Irritants, common complaint of rescuers and patients. Vapors that affect mucous membranes. Combined with moisture, and it has an acidic or alkaline reactions. Acidic or alkaline reactions. Self-defense, chemical sprays, mace, bear spray, things like that. Fixant, substance that displaces oxygen in the air and prevents cellular uptake of oxygen despite adequate availability in the blood. Carbon dioxide, methane, and propane. Health hazards. Nerve poison, anesthetics, and narcotics act on the nervous system developed by the military. War gases, nerve gases, or nerve agents. Solid pesticides, and they have many fatal complications. So BX gas, things like that. Hepatotoxins damage the liver. Cardiotoxins damage the heart and can cause myocardial ischemia and dysrhythmias. Acute myocardial infarction and sudden death, cardiac abnormalities. Hemotoxins affect the blood. Carcinogens, cancer-causing agents. All fossils and organic fuels produce dioxins when burned, unintentional byproduct of many industrial processes associated with the increased incident of respiratory and some other cancers in firefighters. Health effects vary by person. Various symptoms may result from exposure. Some symptoms may be delayed or masked by common illness, such as influenza by smoke inhalation. Some other ones that you or the patients should go to a hospital for. Changes in skin color, flushing, chest tightness, confusion, lightheadedness, anxiety, dizziness, coughing or painful respiration, diarrhea, involuntary urination or defecation, or both. Dim or blurred double vision, photophobia, the fear of, the sensitivity of bright light, loss of coordination, nausea, vomiting, abdominal cramping, salivation, drooling, rhinorrhea, seizure, shortness of breath, burning of the upper airway, tingling, numbness of extremities, or unconsciousness. Sounds just like side effects on a medication commercial. All right, health hazards. We can see these are acid burns or alkalotic burns. They become corrosive when mixed with water and cause severe tissue damage. Corrosives, strong acids or strong bases, alkaline. Brushing off dry powder and what we first need to do, brush off any dry powder and then flush with copious amounts of water. Never try to neutralize an acid with an acid or a base. If it's an acid, don't try and put a base on there or vice versa. You can actually make some pretty wicked gases or other bad things. Not going to show you how, but here's some examples of the substances like sulfuric acid, sulfuric acid, sulfurous acid, hydrofluoric acid, acetic acid, hydrochloric acids, and where you can find those at. Ammonia, potassium hydroxide, magnesium hydroxide, and lime are all examples of alkali. See where they're found. Soft tissue damages. So cryogens are refrigerant liquid gases that can freeze human tissue on contact. Very, very cold, and they can cause pretty wicked burns and burn like, but instead of a burn, it's just freezing the skin and killing everything there. Liquids vaporized cause tissue, and it causes tissue damage. Chemical exposures to the eyes. may cause damage ranging from superficial inflammation to severe burns. Immediately flush eyes with water and try and just continuously flush them. We've talked about connecting a nasal cannula, putting it over the nasal bridge, and just hooking an IV line, IV bag, it up to an IV bag. I can show you guys how to do it in class. It's pretty easy. And then you just constantly flush that out with that semi-neutral substance of being just NS. It works really well. So, response to hazmat emergencies, decisions must be made about rescuer safety, the type and degree of potential hazard, the involvement of other agencies, and protective for the general public. We respond, we got to figure out all that. Most of the time, as paramedics, if you're not on the hazmat team, you are just standing kind of back and allowing them to come to you. Once they get out of the hot and even the warm zone where they get deconned, we have to make sure they are completely deconned, whether they're responders or not, or bystanders or patients involved in the situation. And we have to otherwise we contaminate the back of their ambulance, and even more so, possibly contaminate the hospital that we're delivering to. The first people on scene may not be the most qualified or best equipped. If we get on scene, we notice there's a hazmat issue, back out and make sure we let dispatch know that this seems to be a hazmat situation, and let the hazmat team respond to this. As an example, propane tank, and you can see at the back, that's what I was talking about with the tanks having that very under pressure. That tank that's under pressure has that really rounded edges, and so those are usually under pressure. And propane has its own unique thing where they call it a blevy, and it can basically, it gets so hot until the propane tank explodes very, very largely. It's a very unique explosion, and very, very deadly. So, but that's just from the picture over there. Some things: use your references, use the ERG, try and figure out what's going on. Even if we're sitting there and they're bringing out hazmat patients to you, if you don't quite know yet, start getting a hold of the IC or whoever's running there, figure out what the chemical is. If they're really busy dealing with negating the emergency in that sense, you can be prepping, getting a hold of chemtrack or poison control, and kind of coming up with an idea of how you need to treat this patient and different things that they can have wrong with them. And the ERG is a great source to start. So we have the cold zone, but we have our inner cordon and outer cordon, and the cordon is just no one goes in and out unless it's known. So they're supposed to be there. Then you got to worry about wind, and that's what this is kind of showing, is all of a sudden that pushes that area all the way down. And so for landing helicopters, land them upwind from the incident, so they're not getting contaminated either. Helicopters produce those gale force winds when they're trying to land. They can cause that to be worse. And so if you're somewhere way far away and you're landing helicopters, make sure that have the LZ, or the LZ should be pretty far away. And as you can kind of see in the hot and warm zone, you have the incident going on. Then you have the decon area where part of it's in the hot zone, part of it's in the warm zone, or kind of in the warm zone into the clean zone. And there's a whole process as they set this up. They have this at the hospitals too. They can set up hazmat and all those extra doors into the ERs to the side of that's normally closed, and they have the showers in there. That's meant for a decon, for hazmat decon. So even if they are coming in there, if you're transporting a number of patients, even if it's just one, but patients there, if there's a bunch of patients, the hospital should be made aware, and they will set up their hazmat decon procedure so they're not making sure they don't contaminate the ER. So first agency to arrive on scene has several responsibilities: detect, identify the materials involved, assess the risk of exposure to rescue personnel and others, consider the risk of fire explosion, gather information from on-site personnel and other sources, and confine and control the incident, establish command posts, and define the safety distance and zones. Some of this, if you just happen to be the first medic on scene, you can start. The biggest thing in there is identifying that it's a hazmat scene and starting to figure out what exactly it is, if you see signs. If not, just try and do your best to provide care and are provide safety to the scene around you. Make sure other people don't go out, and if people are leaving the incident, don't just load them right in the back of your ambulance, because now your ambulance is contaminated. Try and stay back and coordinate more resources coming in, and then figure out what they need from you as they come in. So talked about this. The safety zones, something you should probably know too for tests. Hot, warm, and cold zones. Hot zones, a contamination zone where everything is bad. Don't go in there. Warm zone surrounds a hot zone. There's some danger in there, and that's usually where the decon area is at. And this is where a lot of the operations is happening as far as getting things set in there, and then they're moving into the hot zone from there. And so many times you'll be on the edge of the warm zone, kind of in the cool zone area, but you'll be getting patients directly from the decon area. Rehabilitation and medical monitoring. They do this even at normal fires, where they'll come there after they go into a house fire or a structure fire, come out and they have to get decon. And hazmat, it's the same. Might not be as hot inside in the sense of temperature and thermal heat, but they still have. They'll come out there. They will decon. They will get their vitals checked, and they'll get rehydrated so they don't collapse when going back inside. It's just an example of that. Rehab, some places have really fancy rehab areas and some don't. Uh, whether it's on a fire or a hazmat, and just trying to reduce injury and risk to themselves as well as other people. Medical monitoring is something that they tend to handle itself within the fire department here. However, at other agencies or other place locations, many times EMS can be working, and they'll have the training too. But we did it out in Flagstaff, where the private ambulance there would work with them and work on rehab stuff too. So kind of there, and the check on vitals, making sure they're not displaying any signs or symptoms of being exposed, things like that as well. Yep, documentation is important. Uh, After that, we shouldn't have to worry too much other than just our standard PCR documentation. Patient care, activities, triage, and evacuation should be part of the pre-planned incident command structure. Fitting in there, every region kind of has a different way of how they're going to involve the different agencies. Here, the private ambulances have a very little interaction with hazmat other than supporting and transporting the patients post-incident. Primary goals of decontamination to reduce the patient's dosage of material, decrease the threat of secondary contamination, reduce the risk of rescue or injury. Biggest thing of this is making sure everyone is decontaminated and that we're not spreading the hazmat to places that it shouldn't be. Deconning patients. Incidents are often fast breaking and may require rapid decision making if the patient's condition is critical. Perform decontamination and treatment simultaneously. A hazmat incident that is well controlled, not a fast breaking event, can be managed over a longer duration. Preparing the ambulance for patient transport. Contamination of ambulances and equipment can be minimized by preparing vehicles before transporting a partly decontaminated patient. On arrival at a hospital, EMS crews should follow decontamination protocols of the hospital. And so here, wherever you're transporting, many times the bigger hospitals like UMC or wherever else, they have let them know that there's a big incident going on, or someone should, and that there's multiple patients coming, and that they are deconned, but they are coming from a hazmat scene, and so they will set up their own decon procedure to make sure that they don't decontaminate the entire hospital. Follow local protocols as far as deconning things, but deconning anything usually takes, it's a very kind of intensive process. You have to make sure you get everything out of everywhere. And doing it on aircraft is quite a bit worse many times because most of those aircraft are not meant for hazmat, so they have to take apart the entire helicopter, to include if like a patient bleeds too heavily and it seeps down into the avionics. Bad day. All right, guys, that's it for hazmat. If you guys have any questions, please let me know.